Hello everyone. Today we will discuss miscellaneous exercise of chapter 5. Let's start from question number 1. Evaluate iota raised to the power 18 plus 1 upon iota raised to the power 25 whole to the power 3. Right? So first of all we have to solve this iota 18 and 1 upon iota raised to the power 25. So what is iota 18? So I hope you know that how to solve this. So 18, we divide this by 4, right? So it will come 18 divided by 4. 4 4s are 16, then remainder comes 2. So it means what? Iota 4 into 4 into iota square. So whatever remainder that we have to find out that power of iota. So iota square is what? Minus 1. That is equals to minus 1. Now 1 upon iota 25. Again 25 divided by 4. So what's the remainder here? That is 1 only. So it means 1 upon iota we have to find out. So multiply the numerator and denominator with iota. Rationalize this. That is what? Iota upon iota square. Iota square we know that it is minus 1. So it will equals to minus iota, right? Now we'll put the values here. What is iota 18? That is minus 1. 1 upon iota raised to the power 25, that is minus iota. So whole to the power 3. Can we take minus common from here, right? So it will come 1 plus iota cube. Minus cube is minus only, and 1 plus iota whole to the power cube. It means a plus b whole cube we have to find out. That is what? A cube plus b cube plus 3ab into a plus b. By using the identity, we'll expand it. That is a cube, that is 1 cube, plus b cube, that is iota cube, plus 3ab, 3 into 1 into iota, into 1 plus iota. That is what? 1. Iota cube is minus iota. 3 into iota, that is 3 iota, into 1 plus iota. We multiply it, that is 3 iota plus 3 iota square. But iota square is minus 1, so that will become minus 3. So solve it. The real parts, that is 1 minus 3, that is minus 2. Imaginary part, minus iota plus 3 iota, we can write it as plus 2 iota. So outside this minus sign is here. So at last we will open the bracket with this minus sign, that is 2 minus 2 iota. Right? So we have to simplify by using the identity a plus b whole cube. So first of all we will expand that iota 18 and 1 upon iota 25. We will solve it. Then we will put the value here. Then by using the identity a plus b whole cube, we will expand this. That's right. Now in question number 2, for any complex number z1 and z2, we have to prove that real of z1 into z2 equals to real z1 into real z2 minus imaginary z1 into imaginary z2. Right? So we have taken the two complex numbers z1 and z2. Right? That z1 we have taken a plus iota b, and z2 we have taken c plus iota d. So any complex number you can take it here. Solve it for z1 into z2. Why z1? First of all, in left hand side we want the real of z1 into z2. So that's why first we have solved this z1 into z2. We multiply it. How to multiply? I hope you everyone knows that. A into c, ac, plus a iota d, plus iota bc, plus iota square bt. Right? So that is AC plus iota AD plus iota BC. Iota square is minus 1, that is minus BD. Now collect real and imaginary parts. Real part is what? AC minus BD plus iota common AD plus BC. Right? So in left side we need the real part of Z1 into Z2. So what is real part of Z1 into Z2 is AC minus BD. Right? So real of Z1, Z2 is AC minus BD. that we have to prove that is equals to real Z1. So let's check that. A is what? The real part of Z1. C is real part of Z2. That is real Z1 into real Z2. Minus B is what? Imaginary part of Z1. And D is imaginary part of Z2. That is imaginary Z1 into imaginary Z2. So like this we can solve it by taking any two complex number. We'll first find out Z1 into Z2, then we'll find real part of Z1 into Z2, and then we'll check that it is equals to real Z1 into real Z2 minus imaginary Z1 into imaginary Z2. Right? Now come to question number 3. In question number 3, we have to reduce into the standard form. Let's see that how to do. Reduce into standard form. Reduce 1 upon 1 minus 4 iota minus 2 upon 1 plus iota into 3 minus 4 iota upon 5 plus iota. So this we have to reduce it into standard form, right? So how to reduce that? First of all, we'll take LCM. What is the LCM in the first bracket? That is 1 minus 4 iota into 1 plus iota. What will come? 1 plus iota minus twice of 1 minus 4 iota. Right? This as it is. 3 minus 4 iota, 5 plus iota. Right? Now solve this. That is 1 plus iota minus 2, minus into minus plus, 2 into 4, that is 8 iota. Right? Now in denominator also we'll solve it. 1 into 1, that is 1, plus iota minus 4 iota minus 4 iota square. This as it is. 3 minus 4 iota upon 5 plus iota. It's right. So 1 minus 2 is what? Minus 1. Iota plus 8 iota, that is plus 9 iota upon. This we can write it as 1 minus 3 iota. Iota square is minus 1. It means that is plus 4. This as it is. So because first we simplify the first bracket, that is minus 1 plus 9 iota upon 5 minus 3 iota. Right? Now the first bracket is simplified. Now what we do? We'll multiply both. We'll multiply this, that is minus 1 plus 9 iota up into 3 minus 4 iota. So multiply it. That is what? Minus 1 into 3, that is minus 3, plus 4 iota, 9 into 3, that is 27 iota, that is minus 36 iota square. It's right. Now in denominator, that is 5 minus 3 iota into 5 plus iota. 5 minus 3 iota, that is 5 into 5, that is 25, plus 5 iota, minus 15 iota minus 3 iota square. Right? Now after that we'll solve it, we'll simplify it. Simplify the numerator first of all. What we have, that is minus 3, 4 iota plus 27 iota, that is 31 iota. Iota square is minus 1. Right? That will come in denominator, that will come 25 5 iota minus 15 iota is minus 10 iota minus 3 into minus 1. That is equals to minus 3 plus 31 iota plus 36 upon 25 minus 10 iota plus 3. Right? That is equals to minus 3 plus 36 is 33 plus 31 iota. Right? Upon 25 plus 3 is 28 minus 10 iota. Right? So we have this now. But we have to simplify into standard form. So we can again simplify it by rationalizing that. So that is equals to what? 33 plus 31 iota upon 28 minus 10 iota into 28 plus 10 iota with numerator and denominator both. What we do? We multiply the numerator and denominator by the conjugate of this. Right? So solve it now. Now 33 into 28. 33 into 28 first of all we do it. That is what? 924. That is 924 plus 33 into 10 iota. That is 330 iota plus 31 into 28. 31 into 28. That is what? 868 iota plus 310 iota. Right? Upon, that is a square minus b square, that is 28 square minus 10 iota whole square. Right? So what is 28 square? Solve it. That is what? 784. Right? So now we have, that is 924, that is 31 into this, that is 310 iota square. Now 924 plus 330 plus 868. Add it please. 3 plus 6, that is 9. 3 plus 8, that is 11. So 1198 iota minus 310 upon 28 square, that is 784 minus 100 iota square. Right? So what we have now? 924 minus 310. 4 minus 0, that is 4. 2 minus 1, 1. 9 minus 3, that is 6. 614 plus 1198 iota upon 784. Iota square is minus 1. That's why this plus 100. Right? So, in numerator we have 614 plus 1198 iota upon 884. Right? Can we simplify it more? We can take 2 common. What we have? We have 307 plus 599 iota upon 884. Right? Can we simplify this? Can we cancel this too? We will have 307 upon 442 plus 599 upon 442 iota. Right? The calculation is quite long, but we have to solve like this only, and after that we will write it in the standard form, that is a plus iota b. We have to write down in the form of a plus iota b, that is 307 upon 442 plus 599 upon 442 iota. Right? So first of all, solve the bracket, simplify it, then let's multiply this. We have this one. After that, we have to simplify this also by rationalizing the denominator, and at last you find out the standard form of, finally we get the standard form of the complex number, that is a plus iota b. I hope it's clear to you. Just the calculation is here, nothing else. After that, come to question number 4. In question number 4, how to do question number 4? If x minus iota y, the question number 4 is, if x minus iota y, that is equals to square root of a minus iota b upon c minus iota d, we have to prove that is x square plus y square the whole square equals to a square plus b square upon c square plus d square. Right? So how to solve this? First of all, what is given? The given is x minus iota y equals to square root of a minus iota b upon c minus iota d. What is given here? That is x minus iota y is square root of a minus iota b upon c minus iota d. Right? So what we do? First of all, squaring both sides. Squaring both sides, what we have? X minus iota y whole square, that is equals to a minus iota b upon c minus iota d. Right? It's simple. Square root हट जाएगा by doing that squaring both sides. Now the next, what we do? We take modulus in both sides. Right? Take modulus on both sides. After that, can I write this as and in the right hand side we can use the property of modulus again. How we have written? Because we can say that this z square modulus is equals to modulus of z square and modulus of z1 upon z2, that is equals to modulus z1 upon modulus z2. It's right. After that, how to solve it? How to find the modulus? Solve left side and right side both. In the left side, the modulus of x minus iota y is what? What is modulus? The square root of real square part square plus imaginary part square. This is the modulus and this square is already there. And the right side, the modulus of a minus iota b, that is square root of a square plus b square, and in denominator, that is square root of c square plus d square. Right? So you everyone know how to find the modulus. After that, see the result. What we have to prove? We have to prove that x square plus y square, the whole square, is equals to a square plus b square upon c square plus d square. So what we do it here now? If we do that squaring both sides, what we have? That is x square plus y square if we do squaring both sides, we have x square plus y square whole square that is what? X square plus y square. Okay, first of all we can write it as this x square root of x square plus y square. This left side we can solve it. In the left side we have this power 1 by 2 into 2. That is what? X square plus y square. That is equal to square root of a square plus b square upon square root of c square plus d square. Now squaring both sides. So what we have, x square plus y square the whole square, that is a square plus b square upon c square plus d square. Hence, root. Right? So like this, what is given, we have to start it from there. The first step, the squaring both sides. After that, taking the modulus, because we have to find out, you see that in which we have to prove that the x square plus y square, that is a real part square plus imaginary part square. So it means we have to find out the modulus here. So find out the modulus and then use the property of modulus. Solve left side and right side both. At last, we have x square plus y square whole square. That's why again we have done the squaring to achieve our result. Right? So that is x square plus y square whole square equals to a square plus b square upon c square plus d square. I hope this question is clear to you. Now come to question number 5. What is question number 5? Now in question number 5, we have to convert into the polar form. The first part, that is 1 plus 7 iota upon 2 minus iota whole square. Right? So convert it into the polar form. How to convert into the polar form, that we have done. But first of all, we'll solve it. We'll solve it. What we have? 1 plus 7 iota upon 2 minus iota whole square. That is a minus b whole square is what? That is a square plus b square minus 2ab. That is a square 4 plus b square minus 2ab. That is minus 4 iota. Right? So that is equals to 1 plus 7 iota upon, that is 4 minus 1 minus 4 iota. That is 1 plus 7 iota upon 3 minus 4 iota. Right? So obviously we have to simplify it by rationalizing it. That is what? We multiply the numerator and denominator with 3 plus 4 iota. So solve it. 1 plus 7 iota into 3 plus 4 iota upon 3 minus 4 iota into 3 plus 4 iota. So simplify it. 1 into 3, 3 plus 4 iota plus 21 iota plus 28 iota square upon a minus b, a plus b is a square minus b square. Right? That will come, that is 3. 24 iota plus 21 iota, that is 25 iota. 28 iota square is minus 28 upon a square, that is 3 square, 9 minus 16 iota square. Right? As iota square is minus 1, and again it is 9 plus 16. So what we have, that is equals to 3 minus 28 is minus 25 plus 25 iota upon, that is 9 plus 16. Right? So that is equals to minus 25 plus 25 iota upon 25. It's right? So 25 common, so we have minus 1 plus iota. What we have? Minus 1 plus iota. So we have to convert it into the polar form. So in order to convert this into the polar form, what we do? Let minus 1 plus iota is equals to what? R cos theta plus iota sin theta. It means we have to find out the modulus and amplitude here. So solve it. Minus 1 plus iota, that is R cos theta plus iota R sin theta. Comparing real and imaginary part, we have R cos theta is minus 1 and R sin theta equals to 1. By squaring and adding, what we have? r square cos square theta plus sin square theta equals to 1 plus 1. R square equals to 2. So r equals to root 2. It means the modulus is what? The modulus is root 2 here. Right? Now we have to find out the amplitude. In order to find out amplitude, first of all we'll find the quantity, that is tan alpha. That is what? Imaginary part of the complex number upon real part of the complex number, modulus of that. What is the imaginary part? That is 1. Real part, that is minus 1. So that quantity tan alpha equals to 1. So tan alpha equals to 1, it means what? Tan alpha equals to tan pi by 4. Right? Tan pi by 4 is 1 only. In 45-degree angle, that is 1. So alpha is what? Pi by 4. So that quantity is pi by 4. Now we check that the complex number lying in which quadrant. Here the real part is negative and the imaginary part, it means the complex number lying in the second quadrant. If the complex number lies in the second quadrant, then what is theta? Do you remember that? That is pi minus alpha. So pi minus pi by 4, that is equals to 3 pi by 4. So amplitude theta, that is equals to 3 pi by 4. So hence polar form is what? If we have r and theta, hence polar form is r cos theta plus iota sin theta. Right? So r is what? Root 2, that is cos 3 pi by 4 plus iota sin 3 pi by 4. Right? So first of all, we have to simplify it. We have to convert it into the standard form. After that, in this, we'll convert it. We'll find out the polar form by on the same steps which we have done earlier. I hope it's clear to you. These questions are quite lengthy, but we are using the same concept which we have done earlier. Now come to question number 6. Now in question number 6, solve each of the equation in exercise 6 to 9. It means question number 6 to 9 we have to solve the quadratic equation which we have done in our last exercise. So one part we will do, question number 6 I am doing, rest of the part 7, 8, 9 you will do it yourself. 3x square minus 4x plus 20 upon 3. So how we have done? By comparing with the standard form, here we have a equals to 3, b equals to minus 4, c equals to 20 upon 3. What is discriminant? That is b square minus 4ac. That is minus 4 square minus 4a is 3, c is 20 upon 3. That is what? 16 minus 4 into 20, that is minus 80. So 16 minus 80 is minus 64, which is less than 0. Now, therefore, x is what? Minus b plus minus square root of d upon 2a. What is b? That is minus 4 plus minus square root of minus 64. 2a is 3. That is 4 plus minus, what is square root of 64? That is 8 iota upon 6. Can I take 4 common from the numerator? What we have? 1 plus 2 iota upon 6. So cancel it. That we have 2 into 1 plus 2 iota upon 3. Right? So the same steps, just we have to find out the discriminant. It is less than 0 and we will find out the x by using that minus b plus minus square root d upon 2a. Now complete last exercise we have done this only by solving the quadratic equations. So the rest of the part 7, 8, 9 that you will do it yourself. So after that come to question number 10. about question number 10. What is question number 10? If Z1 equals to 2 minus iota, Z2 equals to 1 plus iota, we have to find out modulus Z1 plus Z2 plus 1, Z1 minus Z2 plus 1. Right? So we have to find out that. So what is Z1? That is 2 minus iota. Z2 is 1 plus iota plus 1. Just put the values of Z1 and Z2 in this. And what is Z1 here? 2 minus iota minus of this 1 plus iota. It means minus 1 minus iota plus 1. Solve it. This iota cancel. So in the numerator we have 4. Denominator we have, that is 2 minus 2 iota. It's right. By taking 2 common, what we have? 2 upon 1 minus iota. It's right. Again this modulus 2 upon 1 minus iota, can I write modulus of 2 upon modulus of 1 minus iota? Because modulus of Z1 upon Z2 equals to modulus Z1 upon modulus Z2. It's right. Modulus of 2, can I write this as 2 plus iota 0? It means the real part is 0 here. Right? How to find modulus? That is square root of real part. That is 2 square plus imaginary part, that is 0 here only, upon square root of 1 plus 1. That is what? Square root of 4, that is equals to 2 upon root 2. It's right? 2 upon root 2, we can write it as root 2. Right? So like this we have to simplify it. Here Z1 and Z2 are given. We have to put the values of Z1 and Z2. Simplify it. Because of modulus this, we can write it as modulus of Z1 upon Z2 is equals to modulus Z1 upon modulus Z2. Right? So here 2 we can write it as that 2 plus iota 0, that is the imaginary part is 0, or directly also you can write it as the modulus of 2, that is equal to square root of 2 square, that is 2 only. Directly also you can write it out. And modulus of 1 minus iota, that is square root of 1 plus 1, that is real part square, that is 1, and the imaginary part, that is minus 1, that is whole square is 1 only, that is root 2. And 2 upon root 2. 2 we can write it as root 2 into root 2. Root 2 is cancelled. That will equals to root 2 only. Right? So I hope these 10 questions we have done today. I hope all these questions are clear to you. So go through all the solution. Do practice of this. And in our next lecture, we'll do rest of the questions of